The Bugatti Type 5950B engine represents one of Ettore Bugatti's most advanced pre-war power plants. Evolving from the Type 59, it was a supercharged straight 8 with a displacement of about 4.7 to 4.9 liters. The 1936 50BI update delivered over 400 horsepower thanks to its light alloy block and enlarged supercharger. Technically impressive, the engine featured twin overhead cams, hemispherical combustion chambers, large valves, and a unique oil cooling system. Its 3 Zenith updraft carburetors further improved airflow and fuel delivery, making the Type 5950B a remarkable combination of engineering precision and racing performance. The presents a rare and captivating look into the operation of the historic steam engine installed aboard the Tonnenleger Busard, a vessel originally designed for buoy-laying duties. Over approximately 7 minutes, the footage documents the engine performing a wide range of maneuvers, including forward and reverse transitions, speed adjustments, and demonstrations of nearly every available operating stage. What makes this recording particularly engaging is that the camera is positioned inside the engine room, often right next to the moving components, allowing viewers to observe the engine's dynamics with unparalleled clarity. The Busard is powered by a classic reciprocating steam engine, a type of machinery that once formed the heart of maritime propulsion. In the video, the engine's main features, such as the massive flywheel, polished connecting rods, crankshaft, and valve gear, are seen working in precise coordination. As steam enters the cylinders, the pistons drive the crank mechanism in a smooth, rhythmic motion that is characteristic of traditional steam engineering. The gleaming lubrication points and polished metal surfaces reveal the meticulous maintenance required to keep such an engine in reliable condition. Throughout the demonstration, the crew performs several maneuvers that showcase the engine's responsiveness. One particularly impressive sequence is the rapid switching between forward and reverse, known as Umsteuern. This operation demands accurate control of the valve gear to redirect the steam's flow and thus reverse the rotation of the engine. The video captures this process in real time, highlighting the power and mechanical elegance of the system. Additionally, the engine is shown running at different speeds, from slow, deliberate strokes to more energetic revolutions, illustrating how steam pressure and throttle adjustment directly influence propulsion. Because the camera sits close to the machinery, viewers can hear the deep, resonant sounds of the engine, the steady chuff of steam, the clicking of linkages, and the rhythmic beat of the crankshaft. These sounds, combined with the motion of the pistons and rotating flywheel, create an immersive impression of being physically present in the engine room. Overall, the provides an authentic and detailed presentation of a historic steam engine in full operation. It not only demonstrates the technical principles governing steam propulsion, but also preserves the atmosphere, craftsmanship, and mechanical beauty of maritime engineering from a bygone era. The exhibit features a remarkable pairing of a parallel compound Sulzer steam engine and an MFO flywheel generator, showcasing the engineering ingenuity of early industrial power systems. The Sulzer steam engine, produced by the renowned Swiss manufacturer, is celebrated for its reliability, refined compound expansion design, and smooth delivery of power. In this setup, it is mechanically coupled to an MFO flywheel generator, likely built by Machine and Fabric Oerlikon, which uses a heavy rotating mass to stabilize output and ensure consistent electrical generation. Together, they formed a compact and efficient system, capable of supplying electricity for factories or small power stations during the early era of electrification. Today, the machine appears meticulously preserved as part of a museum collection, allowing visitors to appreciate both its mechanical complexity and the historical role it played in bridging steam power with modern electrical production. The Chevy 350 engine, officially known as the Chevrolet Small Block Vi-8 350 cubic inch, is one of the most iconic and influential power plants in American automotive history. Introduced in the late 1960s, it quickly became a benchmark for durability, simplicity, and unmatched customization potential. From muscle cars and pickup trucks to hot rods and marine applications, the Chevy 350 earned a legendary reputation that continues to this day. At its core, the Chevy 350 features a 90-degree V8 layout with an overhead valve design and 2 valves per cylinder, a configuration praised for its mechanical robustness and ease of maintenance. Although the engine appeared in many variants over several decades, its fundamental specifications remained consistent. It has a displacement of 350 cubic inches, achieved through a 4.000-inch bore and a 3.480-inch stroke. Most versions used a cast-iron block and cylinder heads, though later high-performance models incorporated aluminum heads to improve cooling efficiency and reduce weight. Performance varied significantly depending on the production year and fuel system. Earlier high-output versions using carburetors could deliver well over 300 horsepower, with some configurations exceeding 370 horsepower. Meanwhile, later emissions-controlled versions produced around 145 horsepower, prioritizing fuel economy and compliance with regulations rather than raw power. Despite these variations, the true strength of the Chevy 350 lies in its adaptability. It responds exceptionally well to aftermarket upgrades such as performance camshafts, improved intake systems, and modern fuel injection kits. This makes it a favorite among enthusiasts seeking a reliable foundation for both restoration projects and high-performance builds. A visit to the Brons Engine Museum's open day on March 5, 2016, offered a rare opportunity to step back into the early era of mechanical power. From the moment visitors entered the museum in Appingdam, they were greeted by the rhythmic thumping and steady exhaust pulses of historic bronze engines running in full operation. Throughout the exhibition hall, each machine was carefully displayed with its original controls, fuel systems, and cooling arrangements, allowing guests to observe how these classic engines once powered pumps, generators, and industrial equipment. During the open day, museum volunteers demonstrated starting procedures, switching loads, and adjusting fuel settings, showing the impressive reliability and characteristic slow-running behavior of bronze diesel and semi-diesel engines. The deep, resonant sound of each unit filled the space, creating an authentic workshop atmosphere that fascinated both enthusiasts and first-time visitors. As guests walked among the engines, they could appreciate the craftsmanship and engineering principles that shaped early 20th century power technology. Overall, the event provided an engaging and memorable glimpse into the heritage of Dutch engine manufacturing. The 1920 Deutz stationary engine presented here is a remarkable example of early German diesel engineering and one of the most iconic machines of its era. Built by Deutz AG, the oldest engine manufacturer in the world, this single-cylinder vertical engine represents a period when internal combustion technology was transitioning from simple hot bulb systems to more efficient diesel designs. Its heavy cast-iron construction, large flywheels, and upright cylinder block reflect the robust industrial philosophy of the early 20th century, when reliability and endurance were valued above everything else. This engine operates at low rotational speeds but delivers impressive torque, making it suitable for a wide range of rural and industrial applications. In the 1920s, engines like this powered water pumps, grain mills, saws, compressors, and small generators, bringing mechanical power to farms and workshops long before electricity became widely available. The model shown uses water cooling, with a large cylindrical water hopper above the cylinder to maintain stable temperatures during prolonged operation. Starting a Deutz engine from this period requires skill and patience. The operator first preheats the combustion chamber using a handheld torch, warming the metal until the fuel can ignite reliably. Once sufficient heat is reached, the flywheel is rotated manually, allowing the engine to catch and begin its slow, rhythmic firing. This distinctive beat is characteristic of early diesel engines and is part of what makes demonstrations of these machines so captivating to enthusiasts. The restored unit in the image bears the Rastelli badge, indicating careful preservation and display, likely for educational or historical purposes. Today, engines like this not only showcase pioneering diesel technology, but also celebrate the craftsmanship and engineering heritage that laid the foundation for modern power systems.
smuta.
Dai, che fa? Lascia girare qui.
The Landini L25 is an iconic Italian agricultural tractor that represents a remarkable chapter in early mechanized farming. Also known by its extended designation, the Landini CV25-30. This machine was produced by the renowned manufacturer Landini, whose tractors were celebrated for their durability, simplicity, and strong performance in the field. The L25 stands out not only for its vintage charm, but also for its practical engineering, which made it highly reliable for small and medium-scale farms during its era. At the heart of the Landini L25 is a distinctive horizontal single-cylinder diesel engine with a displacement of 4.312 liters. This large-capacity cylinder allowed the tractor to generate powerful, steady torque, enabling it to handle plowing, tilling, and various heavy farm tasks with ease. Despite being a single-cylinder design, the engine delivered an impressive 25 horsepower at the belt pulley when running at 880 revolutions per minute. This combination of low-speed operation and high torque was ideal for agricultural work that required consistent pulling power rather than high speed. The tractor is equipped with a mechanical transmission featuring 4 forward gears and 1 reverse gear. This simple yet effective gearbox offered farmers the flexibility to choose appropriate speeds for different field conditions, from slow and controlled operations to more dynamic tasks. Its robust construction ensured long service life even under demanding workloads. Beyond its mechanical features, the Landini L25 is admired today as a symbol of historical agricultural innovation. Its rugged build, exposed mechanical components, and characteristic diesel firing sound evoke a sense of craftsmanship from an earlier time. Many restored examples continue to appear at vintage machinery exhibitions, where enthusiasts appreciate the tractor's engineering heritage and its contribution to rural development. The Landini L25 remains a celebrated classic in the world of antique agricultural machinery. The machine in the image is a large, synchronous motor commonly used in heavy industrial facilities. Its large flywheel helps stabilize speed and maintain torque during continuous operation. The massive housing contains the stator and cooling system, while the brush and slip ring assembly provides excitation current to the rotor. Safety railings surround the unit to protect operators. This type of motor offers high efficiency, stable performance, and is well suited for driving heavy mechanical loads.